Okay, in most cases where you're solving a perfect square, you're going to get something like x squared equals 25. And when you take the square root of both sides, you're like, oh, it's so nice. It works out to plus or minus 5. It's a perfect square. And so we get a nice root. Well, when simplifying radicals, if you're asked to solve and it's a perfect square and it works out nicely to that, great. But what if you're asked to solve and it's not quite at a perfect square, it's at something like 24? Or what if instead of square root of 16 being 4, what if it's the square root of 18? So these can be simplified. And this next process I'm going to show you is simplifying radicals. Another way I like to think of it is the hunt for perfect squares as factors. So think of yourself like a little Enola Holmes, a little Sherlock Holmes, where you're looking, what is a perfect square that is embedded inside of a 24 that could be on my list of perfects? Again, what is that list of perfects again? 2 times 2 equals 4, 3 times 3 equals 9, and so on and so forth. Here's my list of perfect squares just to have handy. Okay, so what times what equals 24? Oh, by the way, to solve for x squared, to solve for x, we need to take the square root of both sides. So x is equal to the square root of 24. Uh-oh, this is not a perfect square. So I'm going to break this up into factors. 24 could be broken up into 4 times 6, for example. And this could further be broken up into 2 times 2 times 2 times 3. So this is again called the prime factorization. We're breaking it up into its smallest parts. Anytime you have the square root of a number times itself, or for example, the square root of 4, we can circle this pair and a 2 can come out. What's going to stay underneath? Anything that didn't have a matching pair, so root 6 would stay underneath. My answer in simplifying this radical would be 2 root 6. Instead of saying the square root of 24, we're going to say 2 root 6. Let's go do 18. Let's break it into its smallest parts. Taking the square root of both sides, we're going to get root 18, and we look, oh no, it's not a perfect square. So let's hunt for perfect squares within 18. So for example, 18 could be written as 9 times 2. There's my perfect square, because 3 times 3 makes 9. I'm looking for that number times itself, that perfect square, so a 3 can come out and a 2 stays in. There is my simplified radical. These answers are called the exact answer, because 2 times the root of 6 will give me exactly what the square root of 24 is. If you were to plug this into a calculator and do a decimal answer, the decimal answer from a calculator has to be rounded. So the decimal answer is called the approximate answer. So a decimal answer from a calculator would be called the approximate answer. And this simplified radical that we're studying is our exact answer. All right, let's do a couple of practice ones to finish off. Okay, so this x squared equal to 75, x squared equal to 32, and finally, x squared equal to 98. Okay, so again, we're on the hunt for perfect squares. within the factors of 75, within the factors of 32, and within the factors of 98. So step 1, take the square root of both sides. I get square root of 75, and I notice that it's not a perfect square. So here I go hunting. What perfect square is in 75? Oh yeah, 25. And I can take the square root of 25. The square root of 25 is just 5. So my exact answer is 5 square root of 3. I took the 5 outside because the square root of 25 is 5, and I leave the 3 inside because there's no perfect for that. Okay, square root of both sides, x is equal to square root of 32. I'm on the hunt for a perfect. Well, 32 is 16 times 2, and I can take the square root of 16. It's 4. So my simplified radical comes out to 4 root 2. That is my exact answer. That is my exact answer. Square root of both sides here. X is equal to the square root of 98. Oh no, it's not a perfect square. Let's break it up into factors. Notice that 98 could be written as 49. There's my perfect times 2. Square root of 49 can take the square root, and root 2 cannot, so it just stays underneath. So 7 root 2 is my simplified answer, my exact answer, my simplified radical.